Welcome to this in-depth tutorial on persistent data management in Android apps. We'll dive into Jetpack Compose and DataStore, exploring how to store and manage data effectively in a to-do list app. This video is packed with practical examples, code walkthroughs, and tips to help you build robust Android applications. Let's get started with our slides. A lecture on persistent data management in Android apps by the programming professor. Let's kick things off with the outline for today's video. We'll cover 6 key areas: data store for managing key-value pairs, app settings to configure user preferences, building a settings screen UI with composables, applying settings dynamically to influence app behavior, working with internal and external storage for file management, and saving to-do tasks for persistent task management. This roadmap will guide us through the essential techniques for data persistence, ensuring you understand each component's role in a modern Android app. Persistent data is crucial for apps, as it remains on the device's file system even after the app closes. DataStore handles key-value pairs, supporting strings, numbers, and custom types for flexible storage. App-specific files are stored in private directories, ensuring secure access exclusive to the app. Shared storage allows media files, like photos or videos, to be shared with other apps. Databases provide structured storage for complex private data. Together, these methods, data store, files, shared storage, and databases, form a robust toolkit for managing persistent data, ensuring your app retains critical information across sessions. The Preferences data store is designed to store primitive types, like integers and strings, using key-value pairs with asynchronous operations for efficiency. To create a data store, use the Preferences data store delegate. This provides a flow-based API for storing and retrieving key-value pairs. Keys are created with helpers like string preferences key or int preferences key. The data property returns a flow of current preferences, while the edit function writes updates. This code snippet defines an app storage class, which creates a data store preferences object to manage preferences in a file on the device. It sets up keys using string preferences key, int preferences key, and Boolean preferences key for values like username, high score, and dark mode. It includes a flow that maps stored values to an app preferences data object. It also provides a suspend function to save updates using edit. The write operation runs on a background thread, using with context to avoid blocking the UI. This setup ensures preferences are stored reliably and can be accessed or updated seamlessly, making it ideal for lightweight data persistence in Android apps. Accessing DataStore and composables is made easy with Jetpack Compose's collect as state with lifecycle. This code snippet shows a DataStore demo composable that displays and updates preferences, such as username and high score, in a responsive UI. Inside the composable, you use collect as state with lifecycle to observe preference flows. By using collect as state with lifecycle, the composable reacts to DataStore changes while respecting the Android lifecycle, preventing memory leaks. A button in the UI triggers updates, like saving a new username, ensuring the app's interface stays in sync with the stored data, providing a smooth user experience. Android Studio's Device Explorer is a powerful tool for inspecting the device's file system. You can view saved preferences using Device Explorer in Android Studio. It displays app files in /data/data/package-name/files and DataStore files in files/DataStore, giving developers insight into where data is stored. You can access it via the View tool Windows, Device Explorer menu, or the Open Device Explorer command. Navigate to your app's data folder, then into Files and the DataStore subdirectory. This tool is invaluable for debugging, allowing you to verify file creation and troubleshoot storage issues effectively. Most apps have a settings screen to control behavior and preferences. These screens let users customize their experience, with preferences stored in DataStore for persistence. Common setting types include on-off switches for features like notifications, drop-down menus for single-choice options like language selection, and text inputs for custom values like addresses. These settings enhance app flexibility, letting users tailor functionality to their needs. By storing settings in DataStore, the app ensures preferences are retained across sessions, improving usability and engagement with a personalized experience. The To-Do List app has been updated to include a settings screen. In the app, settings are managed through the App Preferences data class. It includes task order for sorting tasks chronologically or alphabetically, confirm delete to toggle a delete confirmation dialog, and num test tasks to set the number of test tasks generated. These settings are stored in preference storage.kt and accessed via the settings screen.kt composable, with navigation handled by to-do app.kt. This structure ensures users can configure the app intuitively, with settings seamlessly integrated into the app's workflow. We follow best practices by passing preference storage into the ViewModel constructor. This makes the ViewModel testable and keeps it decoupled from context lookups. Dependency injection like this ensures more flexible and maintainable architecture. Integrating the ViewModel factory into composables ensures robust state management. This code snippet demonstrates the to-do screen composable using the ViewModel function with the to-do-viewModel.factory. This setup passes the factory to instantiate the ViewModel with its dependencies, ensuring settings like task order or delete confirmation are accessible. This integration keeps the UI in sync with the ViewModel's state, providing a consistent and responsive user experience across the app. The ViewModel factory is key to dependency injection in the To-Do List app. This code snippet shows a To-Do ViewModel class with a companion object defining a ViewModel provider.factory. This factory injects a preference storage instance, allowing the ViewModel to access app settings. By decoupling dependencies, this approach ensures the ViewModel remains modular and testable, making it easier to manage settings and maintain clean code architecture in your Android app. The list setting composable creates an interactive drop-down menu for selecting task order, such as newest first or alphabetic. This code snippet uses exposed drop-down menu box to display options from a task options list, with an on-item click handler to update the selection. This composable provides a clean, user-friendly interface for settings, ensuring users can easily customize how tasks are displayed in the To-Do List app. The list setting composable integrates into settings screen.kt to manage task order settings. It uses the task order enum to populate drop-down options and updates the task order value in DataStore via a save task order function. This ensures user selections are persisted and reflected immediately in the app's UI, providing a dynamic and responsive settings experience that aligns with user preferences. The switch setting composable offers a toggle for enabling or disabling delete confirmation dialogues. This code snippet shows a simple row layout with a switch component, updating the confirm delete preference in DataStore. This straightforward design ensures users can quickly toggle settings, with changes saved instantly for a consistent app experience. Integrating switch setting into settings screen.kt allows users to control the delete confirmation dialog. The composable updates DataStore's confirm delete value using save confirm delete. When enabled, a dialog prompts users before deleting tasks, enhancing safety and preventing accidental data loss. This integration ensures settings are applied seamlessly across the app. The slider setting composable lets users adjust the number of test tasks via a slider. This code snippet defines a slider with a customizable range, updating numTest tasks in DataStore when the user finishes sliding. This provides an intuitive way to configure test task generation, making it easy to test the app with varying task counts. Integrating slider setting into settings screen.kt allows users to set the number of test tasks dynamically. The composable reflects the numTest tasks value from DataStore, updating it via Save numTest tasks. This ensures the app generates the exact number of test tasks specified, streamlining testing and enhancing user control over the app's behavior. The To-Do ViewModel applies settings from preference storage to the to-do screen composable. It manages task order to sort tasks, newest first, newest last, or alphabetic, confirm delete to toggle deletion dialogues, and numTest tasks to control test task generation. This centralized approach ensures settings directly influence the app's UI and behavior, creating a cohesive user experience. The To-Do ViewModel collects preferences using App Preferences flow in its init block, as shown in this code snippet. It updates state variables like confirm delete, numTest tasks, and task order whenever DataStore changes. Using ViewModel scope launch, it ensures asynchronous updates are handled efficiently, keeping the ViewModel in sync with user preferences for real-time responsiveness. Task sorting in To-Do ViewModel uses the task order setting to arrange tasks dynamically. This code snippet shows a sort list function that sorts tasks by ID, newest first or last, or alphabetically based on task order. This ensures the task list reflects user preferences instantly, providing a tailored and intuitive experience in the To-Do List app. The Delete Confirmation feature in To-Do app top bar uses the Confirm Delete setting to show a dialog. This code snippet demonstrates an alert dialog that appears when Confirm Delete is true, prompting users before task deletion. This safety feature prevents accidental deletions, enhancing the app's usability and user trust. The Create Test Tasks function in To-Do ViewModel generates test tasks based on the numTest task setting. This code snippet loops to add tasks with names like Task 1, Task 2, up to the specified count. This feature simplifies app testing by populating the task list with predefined tasks, controlled by user settings. Android apps use internal and external storage for data persistence. Internal storage is always available but has limited capacity, ideal for small private files. External storage, like SD cards or USB drives, offers more space but may not always be accessible. Scoped storage restricts access to app-specific directories, while the Media Store API enables sharing media files, ensuring secure and flexible data management. Saving to internal storage uses Open File Output to create private files in the app's directory. This code snippet writes a haiku to a file named favehaiku, using PrintWriter for clean text output. Reading uses Open File Input to retrieve the file's content. This approach ensures reliable, app-exclusive file storage for persistent data. External storage requires checking availability with getExternalStorageState. This code snippet writes to and reads from a file in the app's external directory, ensuring data is stored only when the storage is mounted. This method supports larger files and scoped access, making it suitable for apps needing extensive storage. The Task Repository class saves tasks to a file named To-Do file for persistence. Modify task repository.kt with the following code. This code snippet uses Open File Output to write task details, ID, body, completion status, asynchronously with dispatchers.io. This ensures tasks are saved efficiently, surviving app restarts, and maintaining data integrity. Here we add the Add Task Suspend function. Finally, we had add functionality for deleting tasks and toggling the task completed UI element. Loading tasks from To-Do file restores the task list in task repository. This code snippet uses open file input to read lines, parsing each into a task object with ID, body, and completion status. It handles file not found exception gracefully, ensuring the app remains stable even if the file is missing. The To-Do ViewModel integrates task repository for persistent task management. The ViewModel now uses task repository for all task updates. This keeps the business logic clean and consistent across the app. This code snippet shows methods like add task and init task list that leverage the repository to save and load tasks. This integration ties the repository to the app's UI, ensuring tasks are persisted and displayed consistently across sessions. Let's wrap up with a summary of our key points. DataStore manages key value pairs asynchronously, perfect for storing preferences like strings and integers. App settings, including on-off switches, dropdowns, and custom inputs, are stored in DataStore for persistence. The settings screen uses composables like list setting, switch setting, and slider setting to create an intuitive UI. These settings are applied dynamically via To-Do ViewModel, controlling task sorting, deletion prompts, and test task generation. File storage supports internal and external options, with scoped access for security. Task repository ensures tasks are saved and loaded reliably, maintaining data across app sessions. This comprehensive approach empowers you to build robust, user-friendly Android apps. Thanks for watching. Let me know in the comments if there are other topics you would like me to talk about. If you enjoyed this video, please like, share, and subscribe for more content on software engineering and technology. See you next time.